image formation by concave mirror. Today's first topic is concave mirror. Now we will take few cases, and we will, in those cases, we will be putting the object at some place, and we will find the image formed, right? Number one, when the object is at infinity. So in each case, we will find the position of image, the size of image, and the nature of image, right? Suppose this is a concave mirror. This is principal axis. This is pole. This is, say, its center of curvature. This is focus. Now here there are two cases. A, rays. A, incident rays. Incident rays parallel to each other, and also parallel to principal axis. Now suppose this is an incident ray coming from infinity, which is parallel to principal axis. Another incident ray coming to the mirror. Name of the mirror is MM dash. Alright. We know, we have learned in the convenient lines, a ray passing parallel to the principal axis meets at F, and this point of intersection will form the image. This is the reflected rays. Now you can see position of image, it is at focus, size of image, highly diminished, highly diminished to a point size, right? It has become a point size. Nature is inverted and real. Now case B, which is there in your book. This is not there in your book. Incident rays parallel to each other, but not parallel to principal axis. In that case, see, you can very well, if you draw the ray diagrams with help of compass and everything, you don't need to bother about these things, right? Let me make the mirror here. This is the concave mirror. This is my principal axis. Clear? This is pole, this is F, and this is C. Now rays are coming parallel to each other, parallel to each other. So after reflection, they will meet somewhere in a plane. They will meet somewhere in a plane below focus, and this will be your image. Image A dash B dash. Position of image. Position of image in a plane. In a plane. Sorry, what I am writing. In a plane containing focus. Containing focus. Size. I will not write to a point size. It is highly diminished. Only highly diminished. Highly diminished. Diminished nature. Inverted and real. So this is the case 1. When object is at infinity. Okay, now the next case is when object is at a point beyond center of curvature. Okay, that is C. So let's make a diagram first. Suppose this is my mirror concave. This is the pole, and this is the principal axis. P, F, and say this is C, right? Now, the object is kept beyond C. So I'll make the object AB. One ray I take parallel to principal axis, and it will pass through focus. Another ray I will take from center of curvature. Don't worry, I'll extend the mirror. Another ray I take from center of curvature, and we know that the ray passing through center of curvature reflects back. So this is the object AB. Therefore, at the point of intersection, the image will be formed. Image will be A dash, B dash. Now, position of image. Position of image between. See, once you have drawn, you can always say now between C and S. Size of image. Size of image. It is diminished. I will not write highly. Now it is diminished. Nature of image. Do you find any difficulty? Pratyasha, if you draw the ray diagram properly, it will automatically come here. If you use compass and everything properly, measure C, you can draw a circle, na?
Yes.
You can draw an arc and then take a point P and then take the half of that, make a point F, and then draw the diagrams properly. It will automatically come. It will automatically come. Now, there is no need of mugging up all this. People mug up all this. I bang on the ray diagram. I know, I can write. Nature of image is real and inverted. Because it is in front of me. Clear? Now case number 3. When object is at center of curvature. When object is at center of curvature, I will draw the diagram here. Right? So let me draw first of all a concave mirror. This point is P, M dash. This point is F. This point is C. Clear? Now suppose I have taken an object A, B. A ray goes from here parallel to principal axis. See, I am choosing all the convenient rays. I'm choosing all the convenient rays, beta. So this ray will, after reflection, will pass through focus, which we have already studied. Clear? Now I'll take another ray passing through focus. Passing through focus, and we know it becomes parallel to see, drawing on a board, I know becomes little difficult. Parallel to let's put the F here. This point is F. Now here we get an image A dash, B dash. Now this ray has gone like this. It has come back as parallel. So position of image, position of image at center of curvature. Size of image is, now see, it has started increasing. When we are moving from infinity, the image size is growing now, right? So it will be at center of curvature only. At center of curvature only. Same size as object. Nature, real, and inverted. Okay. Next case is when this is fourth. Am I right? When
Yes.
the object, when the object is between C and F, that is center of curvature and focus. Clear? Can anyone tell me where the image will form? Beta, this is getting reversed. It is a reverse case of when the object was beyond C. So this is my pole. This is the mirror, M dash. This is focus, and this is center of curvature. Right? Let me. Now I have to place the objects somewhere here. A, B. Okay. If that is the case, we will take a ray which is parallel to principal axis, and it will go to focus. Now I take another ray from focus only, incident ray. It will become parallel to the principal axis and the image will be formed beyond C, A dash, B dash. Now can you see? The image is also enlarged. So I'll write here position of image beyond. I'm writing only C, but you should write center of curvature and then C. Size of image magnified that is larger than object. Number 3, nature does not change. Nature will be real and inverted. Now let's take case number 5. Case number 5. And gradually, when object is placed at focus. Now what happens? Let's see. Suppose this is my concave mirror M dash. This is the pole and this is my principal axis. Okay. Suppose this is my focus and this is my center of curvature. Now the object is kept at focus, exactly at focus, A, B, right? Now take a ray which passes through center of curvature, a ray taken which passes through center of curvature. I'll have to extend the mirror. So a ray taken which passes through center of curvature which passes through center of curvature gets what? Reflected along the same path. And another ray which passes through, which is parallel to principal axis and then passes through now if you draw properly you will find these reflected rays, these reflected rays are parallel. That means the image formation will be at infinity. When the object was at infinity, image formed at focus. When an object is at focus, image is formed at infinity. So again we'll write position of image at infinity size of image will be highly magnified. Highly magnified. Highly magnified. And we assume that nature is, again, not assume, we have done practicals also. Nature of image real and inverted. And there is a last case of this. Now, sixth and the last case, when the object, when the object is placed between focus F and pole P. Now let's draw the ray diagram first, and everything will be clear. Now suppose this is my concave mirror. Again, I am saying don't draw freehand, use scales and pencils, because I make much better diagram when I draw it on a copy. It's difficult to draw on board. I am not habituated drawing diagrams on board. Okay, now this is my mirror M M dash. This is pole. Say this is focus, and this is center of curvature. Even if it is not required, you have to mark all these things. This is very important. Now we have placed an object A, B. Okay. Or let me little bit, otherwise you people will be confused. Let the object be here. Right? Now, if I take a ray parallel to principal axis, it will definitely pass through, it will definitely pass through the focus after reflection. Right? Now, this is A, this is B. Now, if I take another ray, if I take another ray from center of curvature, and the head of the object. So it will reflect back along its path. Now, can you see these lines are diverging in nature? Reflected rays are diverging in nature, right? So this will appear to meet at some point behind the mirror. So I'll have to extend my principal axis up to this, right? So this is a virtual image A dash B dash form. So position of image behind the mirror, behind the mirror, and size of image, size of image magnified, and nature of image is virtual. This is not, see, the image is forming behind the mirror. So can you see behind the mirror? Can the ray go behind the mirror? Can this go behind the mirror?
No, sir, not possible.
It appears that it is meeting here. So it is virtual, and you can write upright or erect. Upright or erect. So this brings an end to the image formation by concave mirror. Then we will go for image formation by convex mirror. Kindly note it down. This was the last case. Now we have image formation by a convex mirror, right? There are two cases in this also. Number one, when object is at infinity. When object is at infinity. Now I have to make a convex mirror, so I'll make it like this. And this is my principal axis. This point is pole, and its focus is on right of the mirror, and center of curvature is this. Even if you are not requiring center of curvature, this P, F, C, MM dash, these has to be shown, right? Now, if the object is at infinity, then definitely the rays will come parallel to the principal axis, parallel to the principal axis, and after reflection, they will get diverged. This diagram is similar to the diagram we drew for locating the focus of convex mirror. right? So position of image at F, size of image highly diminished to a point size, nature, virtual, and erect. Now, second case is when when object is placed in front of mirror, in front of mirror at any certain distance, or at any distance you can write, at any distance from pole, right? So let's make this diagram also properly. So this is my midpoint. So this will be my principal axis, which can be extended up to this, right? This is this F, and this point is C. Now suppose, and this is the mirror M dash. Don't forget to write all this. And this is pole P. Now if I have kept an object here, right? So a ray will go parallel. Object is AB. A ray parallel to this will appear to diverge from focus. Is that clear? Is that
Yes,
clear?
yes, sir.
Now a ray going to I will have to move the center of curvature here. Center of curvature will reflect back like this, and this will be dotted, right? So this point is C, and I'll extend the principal axis a little bit. Now see, it appears that these two rays are intersecting here, but they are not actually intersecting. So this becomes the image A dash B dash. So position of image, it is between P and F. Size, I will not write highly diminished. Size is diminished, and nature is virtual and upright. Your book, it is written upright. See, virtual, I don't have any issues, and upright, In place of upright, it is quite long word. We can use erect also. This is the end of the convex mirror image formation. We don't have many cases in. The same thing becomes ulta in case of lens. Convex lens has 6 positions. Concave lens will have only 2 positions. That you will learn in class 10. Lenses are there in class 10. So, as I was saying, concave mirror has many uses. So, first use, few are given in your book. First use is use of concave mirror, use of concave mirror as a shaving mirror. As a shaving mirror. Now, what is the purpose of shaving? Bujdurjo, Pratyasha, you must have seen your father shaving.
Yes.
Now, if I have to shave, yes, I know we normally use plain mirrors. Now, if you check the position numbers, point number 6 of ray diagram, can you go back? Can you flip your pages back and see the image formation by concave mirror when the object is placed between F and P? It is used by placing the object. What is the object here? When I am shaving, so object will be my face of a person, of a man, right? By placing the object between the focus and pole of mirror to get a magnified image. This is the application of case number 6. Second use is use of concave mirror, use of concave mirror as a reflector. As a reflector. Now, suppose I have a concave mirror. And this is the pole and this is the focus. Right? if I place a bulb here, if I place a bulb here, I am showing the bulb like this. If I place a bulb here, then light from the bulb will go from focus and become parallel to the this gives a beam of parallel light, right? So we can write if a source of light is placed at the focus of a concave mirror, concave mirror, we get we get a beam of parallel reflected light, reflected light rays, rays. So this is used in torch, whatever torch we are using, the bulb is placed at focus. Searchlight, in searchlight also, which you see in the, you must have seen when a circus comes, they, you know, they move a very strong beam of light in the sky to promote their circus. And headlight also, headlight of cars and other vehicles. Right? Now, acha, chalo, note it down. Then we'll discuss few more uses. There are 5 uses. More or less all are same. Now the third use of the concave mirror, use of concave mirror, use of concave mirror, use of concave mirror as a doctor's hand mirror, as a doctors use some mirrors to see the internal parts of ear and eyes at times. Now let me make the diagram first. how it is applied. This is my pole, this is my mirror dash, right? This is my focus. This is my center of curvature, right? So a parallel beam of light is thrown on the mirror. A parallel beam of light is thrown on the mirror to make this focus, right? All. There are not two mirror, two rays. There are many rays. So all the rays will be converging here. Am I right? Are you getting my point?
Yes,
All the
sir.
rays will get converged and focus, right?
Yes, sir.
Here, intensity of light or the brightness, right,
Yes, sir.
will increase, and the doctor will be able to see the inner parts of the nose, throat, ear, teeth, etc. Right? So we write here if a parallel beam, yeah, mind it. Why the question can be like this also? Why the concave mirror is used as a doctor's head mirror? Then you have to write all this. You have to draw all the diagrams. Now try to understand this. If a parallel beam of light, so this is, you can write here parallel beam of light. Here also parallel beam of light. If a parallel beam of light is incident on a concave mirror, the reflected rays, the reflected rays are converged at focus, right? And the intensity of light, write down this word, it is not there in your book. Intensity of light, you can use within brackets, you should write brightness. Intensity of light means brightness. Intensity of light increases at focus, increases at focus. This helps the doctors to check the inner parts of ear, nose, throat, and teeth. So teeth means dentist, ear, nose, throat means ENT specialist.
Yes, sir.
Take him to an ENT, ear, nose, throat. Clear?
Yes, sir.
Now, use of concave mirror, use of a concave mirror in a solar cooker. The same funda is used. This is your mirror, right? This is your mirror. This is principal axis, right? Now this is focus, right? And the food is kept here. Now what will happen? The parallel beam of light from sunlight will come here. So the sunlight, the beam, uh, the parallel beam of sunlight is converged at focus, at focus, which, at which, at which the cooking material is kept. At which the cooking material is kept. Okay. Now the intensity of sunlight increases at the focus, increases at the focus, which produces more heat for effective cooking. These are all not written in your book. Please mind it, there is no diagram also. Now, fifth use is use of concave mirror in floodlights. Floodlight is nothing but a searchlight only, right? Now, okay, let's write this use separately. In floodlight, what do we require actually?
Yes, sir.
So you have to connect. I normally do it on a, when you come to class 9, I will not be doing it like this. I'll be making a chart. Serial number, position of object, then immediately ray diagram. Then nature, size, nature, position, size, nature, and then applications. So in one shot, everything is done. Are you getting my point? I'll make a chart kind of thing. In chart only I'll draw all this. Please keep your my copy of physics preserved, because many of the topics I'm not going to cover all this in class 9. I'm telling you. I'll ask you to draw. Yes, we will learn. Use of a concave mirror in floodlights. Floodlights are basically diverged lights, right? So in floodlights, floodlights, the source of light, source of light, say a bulb, is placed between focus, focus and pole. Focus and pole to get a diverged beam. Now let's see how we can draw this diagram. See, this is a mirror. Okay. Say this is the principal axis. Right? Okay. This is my pole, and this is, say, focus, and say this is my center of curvature. Is that understood? Now
Yes,
suppose
sir.
I place a bulb here. Suppose I place a bulb here. So lights from bulb lights from bulb in similar way. Light from bulb, they will pass through focus. Sorry, parallel lights will pass through focus, right? And the lights passing through center of curvature will get something like this, right? Now you can see this is a diverged beam, right? So this is also a type of floodlight. You will get a diverged beam of light. Bujurju understood?
Yes, sir.
Because here I am not interested in the image. Here I am interested in the reflected rays. So as a
Okay,
result, I am
sir.
getting what? No, have I made the image? I have not. Not required.
Yes, sir.
What is my requirement right now? Right
So
now,
to
my
get the
requirement is to get a diverged beam. So that is why the light passing through the head of the bulb, right, will reflect back on its path,
yes,
and light passing from the head of the bulb parallel to the principal axis will converge at focus, right? And this will, as a result, this will diverge. Both the rays will be diverged, and we will get a diverged beam. Have you understood this?
yes, sir. The
This is
light
the
ray.
application of sixth position.
Sir,
Yeah.
the light ray from the head of the bulb touches the surface and then reflects back and passes through the center of curvature.
No, I have taken two rays. Be very clear.
Okay.
One ray which is actually passing through center of curvature from the head only, right?
Yes, sir.
It is getting reflected back. The
Yes,
other
sir.
ray is, it is getting reflected back. In fact, it is like this. In fact, this is something like this.
Yes, sir. Along its
This is
path, it
getting
is reflected.
reflected. And this is the parallel ray, which will pass through focus, and as a result, we get a diverged beam. Let's not go behind the mirror. We are not interested here in the image. We are interested in the diverged beam. Is that clear?
Yes, sir.
So that ends the use of concave mirror. Now, let's discuss some uses of convex mirror. Number one, use of convex mirror. Convex mirror as rear view mirror. You understand what is rear view mirror?
Yes, sir.
Said the mirror attached right
The
next to
mirror
the
will fitted in the car to see the rear view. Back to you.
yes,
Now, why a
yes.
convex mirror is used? Why not a plane mirror?
So that the driver can see in the back what is happening.
So driver can see in the back what is happening by using a plane mirror also.
So
If I
plane
put a
mirror
plane mirror,
doesn't give the full view. Convex mirror gets a bigger view.
correct. So if I use a plane mirror, right, like this, right, now there are two incident rays. Say these are two incident rays. So at this point, I'll have to draw the normal. At this point also, I'll have to draw the normal. So this angle should be equal to this angle, and this angle should be equal to this angle. So here is my eye, right? Here is my eye. Now this is the view I have got using plane mirror, right? Now similarly, in place of a plane mirror, if I use a convex mirror, what will happen? I will show you. Suppose this is a light ray and this is another light ray, right? This is another light ray, and then after reflection, I'll have to draw the after reflection. If I draw this has become little. Okay, let me draw this diagram somewhere else. Let's draw it here. Why I was trying, let me see if I can manage here only by making the mirror little small proportionately. Right? Now this is the principal axis. This is pole. This is F. This is C. Right? Now if a light ray is coming like this, we have to draw the normal here, which will be like this. And after reflection, similarly, if a light ray is coming from here, after reflection, it will go like this. Now, can you see this view is wider, So to get a wider view, to get a wider view, which enables which enables which enables to to make the driver driver see a wider range of traffic. Traffic means collection of car, truck, bus approaching the car. So this is the first use. Please note it down fast. Next use is use of use of convex mirror convex mirror as a reflector in street lights. Now, what is the objective of street light? So it should diverge, no? The light. We all have seen a street light looks something like this. There is a bulb, right? So it should
Yes.
spread at a very large distance or not.
Yes, sir.
So what do we do in this street light? We use the convex mirror, and put a lamp over here, right? Light from lamps will go like this. Now, if I draw a tangent, a normal here, and if I draw a normal here too, it will diverge the rays. So this is how you get a wider range, right? The light from bulb, the light from bulb placed in front of the convex mirror, right? Convex mirror diverges the incident lights to over a large area to spread the reflected light over a large area. Now we will write third use also. Use of convex mirror. Use of convex mirror as a vigilance mirror. Vigilance means in jewelry shops it used to be earlier. Nowadays we have CCTV cameras. Clear? So in big shops, departmental stores, departmental stores, airports, railway stations. It used to be earlier. Nowadays it is not used. Convex mirror convex mirror are used to have are used to have a view on the customers walking in and walking out to prevent from any theft from the store. So these are also called anti-theft mirrors. Anti-theft mirrors. Funda is same, wider view. Funda is same as a wider view in rear view mirror of a car. You can see a wider view, na? If I am sitting at the billing table and there is a small convex mirror is installed at the corners of the shop, I can see what is happening in the entire shop. Not
Yes,
even
sir.
walking in or walking out. If someone is taking something in and putting in his pocket, he will be caught. Right? But nowadays
Yeah.
these are not used. Please understand this. Yeah, solar cooker is still in use, concave mirror. Those are used. But nowadays rear view mirror is used definitely. Street light reflector is also used. Here there is a revolution called CCTV camera, closed circuit television camera.
Sir,
Yes,
what